Okay, section 1.2, your first calculus video. And this one we're watching in class so that you can see how I expect you to watch the videos. Finding limits graphically and numerically. Now, we have just learned a little bit of how to use our calculator. We've discovered that a limit is a y value that a function is approaching as it approaches an x value from both sides. So we come to our formal definition of limits. Notice the notation, LIM, as x goes to c, that's smaller and below that, of a function of x is L. As x approaches c on function f of x, the y values of f of x become arbitrarily close to a single number L. L is the limit of f of x. L is a y value. So think of spelling limit incorrectly with y's instead of i's. That'll help you remember it is the y value that you are approaching. Now, more formal notation, when we say the limit as x approaches c, we mean from both sides of c. So we write it like this. If the limit as x approaches c from the left of f of x equals the limit as x approaches c from the right of f of x equals L, then the limit as x approaches c on our function of x is L, the limit exists. Then the limit, which is L, exists. You need to know this very, very well. When we say the limit as x approaches c on f of x is L, we mean from both sides of c. So both conditions have to be met, and that is going to be a very important topic as we move along. Conditions that must be met. Now we can evaluate limits by making a table on the graphing calculator and asking for values close to c. We did some of those in class today. As we approach c from the left, that means values less than c, and from the right, that means values greater than c. The y values must approach the same value. Otherwise, the function is said not to have a limit as x approaches c. Now, when you watch the videos, one of the things that's going to show up is it'll say, see example, page 50. So example 3, page 50, and in this problem, I noted it's similar to the investigation of number 8 and 9 that we did. So I'm going to turn in my textbook, and if I were watching this video, we would stop and go and look at example 3 on page 50, which obviously talks about something we just looked at. So here is the textbook. And by the way, this is a college class. I recommend strongly that you learn how to read your textbook. You must learn how to read it. And we're going to go to page 50, which is right here. It says, show that the limit does not exist. So when I look at this, notice that the absolute value of x over x is our function, and we want to look at it as x gets close to 0. So we want to show as x gets close to 0 from the left and the right side of 0. Here is x equals 0, the y-axis. From the left side of 0, pick a number for x, negative 2. So the absolute value of negative 2 over 2 would be, well, the absolute value of a negative number is the opposite of that negative number, so that would be 2 over negative 2, which is negative 1. Pick a number bigger than 0. Let's try positive 2. The absolute value of positive 2 is 2 over 2 is 1. You can see as we move from the left side and the right side, as x approaches 0, I am approaching two different y values. And so, since we are approaching two different y values, this tells us the limit does not exist. Okay, we'll talk about this notation in a little bit. Delta, that's the letter for delta. Okay, if a function does not have a limit because it approaches different y values from the left and right of c, then we say the limit of the function does not exist. Very important. Notice that for the limit to not exist in our concept, It is going to be because it approaches different y values. Approaches different y values does not exist. If the limit approaches infinity as x goes to c, in other words, both sides as x goes to c, both branches go towards positive infinity or both goes towards negative infinity, the limit of the function is said not to exist because there is no way to bound infinity. But we must say does not exist because the limit goes to infinity or negative infinity. Don't just say does not exist. We are reserving does not exist for the time when the function approaches different y values. Because this label does not exist is reserved for functions which have different right and left-handed limits as x goes to c. Then it says, see example 4, page 50. So here is example 4 on page 50, where we have a function, 1 over x squared. We know what this function is going to do. And we can see as we go to 0 from both sides, we are going towards positive infinity. So the function is not approaching a real number as x approaches 0. So you conclude the limit does not exist because the function is approaching positive infinity. If the limit oscillates as x goes to c, we say the limit does not exist. And then it says, see example 5, page 51, and look at it on the graphing calculator and zoom in repeatedly. We'll do that in a minute. But here is example 5 on page 51. If we take this limit as x goes to 0 of the sine of 1 over x, and we're going to be in radian measure in our calculator so that we can enter strange values like this as we get close to 0, you can see what is happening graphically. So you might want to try that on your calculator. And the funny thing is when you zoom in, this just gets worse and worse. Okay. In fact, here is a graph where we are zooming in. Notice the x's are going from negative 0.25 to positive 0.25. You can see that it is just getting closer and closer to 0. We could go from negative 0.001 to positive 0.001. You will see more of this. Conclusion. There are 3 types of behavior which result in a limit does not exist. One is when the function approaches different values as x goes to c from the left, see that notation, and from the right. Notice from the left as x goes to c from the left, that looks like a little negative sign. As x goes to c from the right, that's a little positive sign. Okay, so we would say the limit does not exist. The next situation was as the y values on f approached infinity or negative infinity as x went to c. This is called an infinite limit. We'll talk about that in a few sections. And it's graphically represented by a vertical asymptote. We saw that in example number 4. And then we say the limit of f of x as x approaches c is infinity. We can say f of x becomes infinite as x approaches c. We can say f of x increases or decreases, depending on what's happening, without bound as x approaches c. Okay? And then the last situation occurs when f oscillates as x goes to c, and we saw that in example 5. Now, when you go on to college, you will learn about something called a formal definition of a limit, and we will actually look at this a little bit later on in this year, but here is a little bit to know. A limit, let us recall, is a y value, okay? So this says, let f be a function defined on an open interval containing c. Open interval meaning it does not contain the endpoints. And let L be a real number. The statement, the limit as x goes to c on function f is L, means that for each epsilon that's positive, that epsilon is a number, and it is a y value that is going to get added to and subtracted from the limit. So for every epsilon that is positive, meaning bounding the y values this way, there exists a delta that is positive, adding to c, subtracting from c. There exists a delta that is positive such that if the absolute value of x minus c is positive and less than delta. In other words, if the distance from C is less than delta. Now, if we are on an open interval, we are not containing C plus the delta and C minus the delta. We're not containing those x coordinates of our function. So that's why this says less than delta, because we will be traveling to the right and to the left a distance smaller than delta. So adding or subtracting delta, and we're within that interval. And it says there exists a delta such that if we stay within that interval, then my y value, that is my limit, will be bounded by these y values of the function, and that is going to be less than some number called epsilon. Now, later in the year, we'll talk about this more in more depth. There are examples you can look at on pages 53 and 54. Sometimes what we do with this is we want to know, look, I need my function to be within 1/1000th. I need my error away from this limit to be within 1/1000th, means 1,000th bigger than this y value and 1,000th less. So if I want to look for my limit such that it is bounded by these y values, I can find what x values will it take for the y values to be bounded. And that's a very important concept a little bit later on in calculus. So we'll look at that later. Don't get too worried about this epsilon delta. Later in college, you'll probably have to do stuff with it depending on what track you take for your college pursuits. Now, at the end of each video, there will be TPs. These are try it problems. And after you've watched the video, you will go try those problems. And you're going to write them down. Most people in previous years have just written it on the blank page of the lecture manual. And you're going to try it and write it down. Now, of course, you can go and find the answers to this online, and these are odd numbers, so you can certainly check the back of your book to see if you're correct. That's fine. But try it before you look up information. This is how we're going to gauge if you understand what's going on. Now, normally what will happen is the video that we just watched, you would have watched for class today. You would have already tried these problems. We will see if there was any conceptual problem for you on the try it problems on the TPs when we come back to class. I will highlight the section you had the video over, and then you will work more problems. So if this were what was due for today, you would have watched this video, you would have tried these problems, and then today I would have talked a little bit more about it, and we would have spent a lot of time working other problems. Then you would have LOPs, learning opportunities, and that would be something you will do in the group work that follows the 30 minutes of big group time. You are going to have homework after today's class. Your homework is going to be, it's on the hub, but it is going to be to watch the next video, which is section 1.3, and do the TPs for that. That's what you will do. Anything you do not finish in the working time when we have our group time, and the video and the TPs for the next class, that's what you have to get done. Right? You'll get the hang of it. This is all new for everybody, but you're going to be awesome. So I hope you have a super day, and I'll see you later.